everyone, welcome to CUET mock test series brought to you by Toppscholars, the smart learning app. In this session, we will discuss about the mock test series for the mathematics subject. The area bounded by the curve y equal to x square and x equal to y square is. So, we have to find this area. The options that we have are, the option 1 is 1 by 3, then we have 1, then we have 1 by 2 and 1 by 4. So, now students, let us again make the figure. We'll then find the points of intersection and then we'll decide which curve will be first, which curve will be second in the subtraction part. So, here in the figure part, you have to realize that y equal to x square represents a parabola, and because it is x square, it is the upward parabola. So, y equal to x square will be this parabola. Next, we have x equal to y square. X equal to y square, students, because we have y square, it's going to be the right side parabola. So, this is y equal to x square and this is x equal to y square. First of all, students, we have to find the point of intersection. So, for that we will solve the equation simultaneously. The value of y here is x square. So, in this y, we can replace the value with x square. So, we get x is equal to x square the whole square, which means x will be x raised to 4. We'll take it to the other side. When we solve this, we'll get x raised to 4 minus x is 0. The students, you take x common, we get x cube minus 1 is 0. From here, we want the real solutions, which means the solution will either be x equal to 0 or x cube equal to 1 means x equal to 1. Obviously, there are two imaginary solutions also, but let's not talk about that right now. So, here the first point of intersection is origin and the second point of intersection has x coordinate 1 and the y coordinate will be x square. So, even that is 1. So, now students, we have found both the points of intersection and now we can proceed with the calculation part for area. For area, students, it's going to be upper curve minus lower curve. This is the area which we are supposed to find. The upper curve, look at the upper curve, it is simply x equal to y square, which means if we make y as the subject, you have to take square root, y will be root x. Look at the lower curve. The lower curve is this curve y equal to x square, which means students, area is simply going to be equal to upper curve minus lower curve. Here the upper curve is root x, the lower curve is x square. So, now let us go ahead and integrate. So, now students, area will be equal to integration of 0 to 1. The upper curve was x square minus integration 0 to 1. The lower curve is root x. Integration of x square will be equal to x cube by 3. So, this is from 0 to 1 minus integration root x, students, you have to realize root x simply means it is x to the power half. The integration formula is x raised to n plus 1 upon n plus 1. So, half plus 1 will become 3 by 2. So, we get x to the power 3 by 2 upon 3 by 2 and that is again from 0 to 1. So, now its upper limit minus lower limit, 1 cube minus 0 cube will be 1. So, this will be 1 by 3 minus this is 1 raised to 3 by 2, 1 raised to any number is 1 minus 0 raised to any number is 0. So, this is 1 minus 0, which is 1 upon 3 by 2, which means students, we have 1 upon 3 minus this goes in the numerator. So, this will be 2 by 3, which means we get the final answer 1 by 3. Area can't be negative. So, the answer is 1 by 3, which is option A. With that, we complete this particular question. Area in this case is 1 by 3. The next question that we have is a similar question. The area bounded by the curve x square equal to 4y and y square equal to 4x is dash, and these are the 4 options that we have. So, students, again we have two parabolas. Let us first go and make the figure. So, the first parabola is x square equal to 4y, which will be an upward parabola. So, the figure for this is going to be upward. So, this is x square equal to 4y. The second parabola y square equal to 4x is a right side parabola. So, this is the right side parabola, y square equal to 4x. and this is the area, students, which we are supposed to find. Now when you go ahead, students, and find the point of intersection, now we'll have to find the point of intersection by substitution. So from equation 1, that is x square equal to 4y, y will be x square upon 4. So we'll replace the value of y over here. So we get x square upon 4, the whole square, which is equal to 4x. When you solve this further, students, you will get x raised to 4 upon 16 is equal to 4x. From here you cross multiply, you will get x cube is equal to 16 into 4 is 64. And when you take the cube root, the answer is going to be 4, which means the x coordinate is 4. The y coordinate will also turn out to be 4. So students, now we can go ahead and integrate. Area is going to be upper curve minus lower curve. So it is integration 0 to 4. The upper curve in this case is this curve, which is the right side parabola. So from here, y will be square root of 4x, which is 2 root x. So 2 is constant, we keep it outside and we integrate root x minus. When we integrate the second part, students, the function is x square equal to 4y. So y is 1 upon 4 and x square will be integrated from 0 to 4. So let us go ahead with the integration. Root x, students, is x to the power 1 by 2. So it will be plus 1 in the power and in denominator. So x raised to half plus 1 is 3 by 2 upon 3 by 2 from 0 to 4. We have minus 1 by 4, integration x square will be x cube upon 3 from 0 to 4. When we solve this for the students, this 2 goes in the numerator. So we have 4 upon 3. Now here we substitute 4. So we have 4 raised to 3 by 2 minus 0 raised to anything is 0. This is 1 upon 4 into 3, which is 12. And students, this is 4 cube. So that will become 64. For the students, 4 raised to 3 by 2 is what you have to calculate. Students, 4 is 2 square. So that 2 in the power will get cut. So this becomes 2 cube, which is 8. Minus over here you can cut the 4. So you will get 16 upon 3. So we have 32 upon 3 minus 16 upon 3. We can subtract the numerators and 32 minus 16 will become 16. So the final answer is 16 upon 3 square units. With that, we complete this question. The correct answer to this is option B, 16 upon 3. With that, students, we complete this question. Let's proceed to the next question. The next question that we have is, we have to integrate sine 2x upon sine x, and these are the 4 options that we have. So let us go ahead and integrate sine 2x upon sine x using the suitable trigonometry formulas. Now students, sine 2x and upon sine x means the numerator angle is 2x, denominator is x, so we will use the double angle formula. Sine 2x is simply 2 sine x cos x upon the denominator is sine x. So here sine x gets cut, 2 is outside, we have integration of cos x. Students, integration of cos x is simply sine x. So the answer is 2 sine x plus c. The correct option will be option C, 2 sine x plus c. The next question that we have is, we have a vector a bar which is a unit vector. We have to simply find the value of p, and these are the options that we have. Now students, unit vector is a vector whose magnitude is 1. How to find magnitude of a vector? So magnitude of a vector is simply square root of, just square and add the coefficients. Coefficient of I cap is p, so p square, plus coefficient of j cap is p, so p square. Coefficient of k cap is 2p, so this will be 2p the whole square, and that is equal to 1. We square both sides so that the root is gone. So we have p square and 4p square, which becomes 6p square, which is 1. So from here, students, p square is 1 by 6. You take square root, but only positive square root because magnitude can't be negative. So we have p is 1 upon root 6. So that is the answer. The correct option is B, 1 upon root 6. The next question that we have is, we have to integrate 1 upon 2x square plus x minus 1. So here, students, these are the 4 options that we have. You have to realize, students, that to integrate this function, we have to use the method where we create a perfect square in the denominator. For that, we have to first take 2 common from the denominator. So we'll take 2 common outside from the integral. So we have 1 upon x square, x becomes x by 2, minus 1 becomes minus 1 by 2. And now you have to think what should be that third term which we should add in the denominator and subtract to make a perfect square. And for that third term, we have a formula. The third term is given by half into coefficient of x the whole square. The coefficient of x here is 1 by 2. So it's half into 1 by 2 and the whole square. So this is going to be 1 by 4 square, which is 1 by 16. So we have to add 1 by 16 and subtract 1 by 16. So we have half integration of 1 upon x square plus half x plus 1 by 16, and we have minus 1 by 16, and minus half is copied as it is. Let's solve this further, students. So in the denominator, this becomes x plus 1 by 4 the whole square. Here students will take LCM, we'll just multiply, divide this with 8. So minus 1 minus 8 becomes minus 9 by 16, and 9 by 16 is 3 by 4 the whole square. And now students, we can use the formula for integration 1 upon x square minus a square. So here students, we have 1 by 2. The formula is 1 upon 2a. So 1 upon 2 into a over here is 3 by 4 into log mod x minus a upon x plus a. Do you realize, students, that x minus a will be x plus 1 by 4 minus 3 by 4, and x minus a will be x plus 1 by 4 plus 3 by 4. So in the numerator we have x minus a, in the denominator we have x plus a. Let's solve this further, students. 2 into 2 is 4. It gets cut with this 4, which means we are left with 1 by 3. So the constant term outside will be 1 by 3. Here we have log. We'll have to take LCM within that log. When we take LCM, students, this is 4x and 1 minus 3 becomes minus 2 upon 4, and in the denominator we have 4x and 1 plus 3 is 4. So this is 4x plus 4 upon 4. Do you realize, students, upon 4 will get cut. So we are left with 4x minus 2 upon 4x plus 4. Last step, we can just simplify this further. We can take 2 common. So this is 2x minus 1. We can take 2 common. This is 2x plus 2. And now, students, we can cut this 2. The final answer is 1 upon 3 log mod 2x minus 1 upon 2x plus 2 plus c. With that, we complete this question. We'll check the correct options. The correct option here is option D, 1 upon 3 log mod 2x minus 1 upon 2x plus 2 plus c.